Hello, welcome to a special episode of the Data Exchange Podcast. In this episode, I'll go over uh, the trends and topics that I'm particularly interested in following this year, 2024. We normally come out with this episode early in January, but better late than never, I suppose. And it just so happens that I've been giving this presentation informally to some friends. So I thought I would share it to a broader audience. So one thing to note is that many of the things that I will discuss here are related to AI and machine learning, not so much to data engineering and big data. All right, so topic number one, basically the democratization of hardware for generative AI. So I will focus on the data center, the server side. So on the one hand, you have for CPUs, normally inference and fine tuning and pre-training of large language models you associate with NVIDIA GPUs. But more recently, there's some interesting developments happening on at least inference for CPUs. And that we can trace back to some of the same tricks that people learned, refined, and started using widely in computer vision. These are things like quantization, pruning, and sparsity. So Intel, for example, has a few efforts out around quantization and open source projects which let them do inference on Intel CPUs. And then a startup called Neural Magic does both sparsification and quantization, and in which case they can do inference and even fine tuning on CPUs. And then the other interesting development here is the emergence of AMD GPUs as a viable alternative for fine tuning, inference, and even pre training. And to this, I refer you to recent work by my friends at Lamini, which you can find at lamini.ai. There, they basically explain how they worked with AMD to basically make sure that they can run all the open source popular large language models on AMD GPUs. At this point, this includes fine tuning and inference. And to paraphrase one of the founders of Lamini, Greg Diamos, their CTO, I think the surprise to most people here is the readiness of AMD's open source software stack, their equivalent of CUDA called ROCm. So by Greg's assessment, ROCm was maybe 85, 90% there. And so what they needed to do was do the remaining 10%. So the next topic I'm keen on is that with the rise of AI, with more and more companies interested in building, fine tuning, and deploying generative AI models, I think this will require some rethinking on the part of enterprises about how they develop software, how they build software, how they test it, how they deploy it. So this will involve updating a lot of their processes around testing, integration, and deployment. So I think that this might be a good opportunity for startups who are building tools to think through, what are the enterprise practices and tool sets and how they can adapt them for generative AI. And on a related front, as more and more companies use AI, in particular generative AI, these are very computationally expensive and intensive applications. So I think there might be some necessary investments on the infrastructure front as well to basically tailor their compute infrastructure to optimize AI performance, which includes latency, efficiency, and reliability. And here on the software front, right? So you have open source projects like the distributed computing framework Ray, and championed by a startup called Anyscale, which you definitely should check out. But on the hardware front, a recent guest on the podcast, Brian Cantrell, the co-founder of Offside Cloud Computer, they're doing a lot of interesting work around, reinventing and or revisiting hardware for cloud computing. Basically, how do you build hardware that is customized and optimized specifically for cloud computing scenarios? And definitely something to check out if you're going to get serious about bringing some of these foundation models in-house. And as many of you who listen to this podcast regularly know, I'm particularly keen on data tools for generative AI. I frequently point out that about 5-6 years ago, there was a rise in data engineering tools, data quality tools, data pipeline tools, ETL, ELT tools. But those tools were aimed at the structured data, so data that would land in a data lakehouse or data warehouse. So we need similar tools for the kinds of data that we need for generative AI. Here, my prototypical example at the moment is in computer vision. It's a company called Visual Layer, so visual-layer.com. And they have an interesting project called FastDupe, as well as a hosted version which has a nice, slick user interface. And there, what they can do is ingest all of your images, help you find duplicates, help you find blurry images, help you find mislabeled images, anomalies, and so on and so forth. So the end result is you can have someone who's not a programmer wade through billions of images and get your computer vision data in a better state for whatever your task will be it fine-tuning or training. On the language side, we have a new startup called lilacml.com, and they're doing something similar to what Visual Layer is doing in computer vision, although they're very much in the early stages. So Visual Layer is further along. They have enterprise customers. Their software has been used to do billions and billions of images. But definitely worth checking out Lilac. At least Lilac at this point can do really can really help you as far as helping you find errors in your data, because they have an open source tool and UI that will help you cluster your text data, and that will allow you to wade through large amounts of text very quickly. And there's another interesting startup called Unstructured, which is more earlier in the LLM pipeline. So I think they focus mostly on information extraction. So how do if I have a bunch of PDF files or web pages, how do I ensure that I get all of the requisite information I need from those files? And so the idea here, as many of you who have done retrieval augmented generation may know, basically a lot of it really boils down to your ability to extract that information from your underlying data sources. So the other thing that I'm following as far as unstructured data for LLMs, and this is much early. on is something that has an equivalent in structured data. So the scenario here is maybe I need to work with another party and collaborate with them, or maybe I'm in a different part of the company and I need to access data, and that data has very, very kind of strict is privileged data, right? So traditionally, people who collaborate do that using data clean rooms, and data clean rooms are used, uh, for example, for financial services companies who want to work with each other, right? So each company comes to an agreement, and then they do some data managing, anonymization in the clean room, and then the downstream use cases might be BI and analytics, could be machine learning and predictive analytics. So traditionally, when people do data clean rooms, they may do things like use hardware enclaves, right? And hardware enclaves are great, but maybe in certain scenarios they are not enough because the data in an enclave is not encrypted. So this specific method may not always comply with certain regulations. The other trick that people do may be to hash the data or add noise to the data, but either way, right? So adding noise, you may have to trade off between privacy and accuracy, right? In that scenario, and then in the case of hashing, it might still be prone to dictionary attacks. And then some people may say, well, what about federated learning? But federated learning, unfortunately, does not support one of the key uh, uh, reasons for collaborating on data, which is to match data matching, right? So, and also it's a pretty complex technique, and even with that, it's still subject to attacks and data reconstruction. So friends of mine, Pyte.ai, have been recently kind of exploring the use of another technique called secure multi-party computation for LLMs. So here, they want to explore they already have it working for prompting and inference and fine tuning. And then the next step now is model pre-training. But I've written about what they're trying to do, and I will direct you to the episode notes for more details. So the other topic that the next topic I want to talk about is generative AI on the edge, right? So just like all these computer vision models and speech recognition models got pushed out to the edge on phones, on cameras, on sensors, there's no reason not to expect that LLMs will also start appearing on the edge. And here, there's some early signals from Apple through recent publications that I will link to in the episode notes, where they explore a couple of new techniques called sliding windows and row column bundling. But also, even more concrete, a startup called Useful Sensors. If you were at the AI conference in San Francisco last year, they had a booth where they showed a really low cost device for speech transcription in real time. And the same group is now exploring adding LLMs to the same sort of devices, right? So by that I mean, the hardware that is relatively affordable and can run on the edge and has the model offline, right? So. And then the other thing that piqued my interest in as far as generative AI on the edge is the rise of web GPU. which is a new web standard that provides direct access to GPUs on web browsers, right? So what are the implications of web GPU? So now, taking that a step further, and this is a lot more speculative, is that if you're going to deploy generative AI on the edge, you can imagine very future scenarios, and maybe this is something startups can work on, where the same generative AI models can learn from the sensors themselves, right? So, and there's huge advantages if you can get that to work, right? So the data, your supply of data might be virtually unlimited, and that data will not be mediated by human interpretation. But in order to get this to work, there's a lot of details I have to admit, right? So first, you've got to improve your algorithms, right? So both unsupervised and self-supervised, so that they can continuously learn. And then you might have to come up with multimodal learning techniques, because you might be looking at multiple data streams coming at you simultaneously. So the next trend I'm going to talk about has to do with how we actually use LLMs today, right? So typically, the most simple way to use an LLM is to prompt it and then get an output. Slightly more complex is to prompt an LLM, get the output, pass it to the same or another LLM, and then finally use the output, right? So that would be a pipeline. And then another usage pattern is what I call the ensemble, right? So you may have a prompt and you pass it to multiple LLMs, and then maybe you use another LLM to kind of aggregate all these different responses to produce a final output. But now a more common pattern is what most people call the mixture of experts architecture. And this has to do with taking your prompt, passing it to a model. That model will decide what LLM to pass it to. So if it's a coding problem, it may say, oh, this is related to SQL, go here. This seems like a Python error, go here. Or this seems to be something to do with another programming language, go to another LLM, right? So with all these usage patterns, one interesting thing to think about is how does that impact how we build our LLM applications. So before we had this notion, we were beginning to see this notion of AutoML, right? So where we have labeled data, we pass it to an AutoML service, and then this AutoML service will build build the right model based on the data, right? So one can speculate that maybe we would have something like that, right? So here's some fine-tuning data. We already can fine-tune it, but maybe now we expect the service to do more than that. Maybe we expect the service to come up with a much more complicated computational graph that mimics that mixture of experts pattern. And by the way, the idea for this comes from Anyscale, because they have a coding assistant that they didn't develop automatically, but does rely on a mixture of experts in a computational graph in order to answer the right question. So one can speculate that maybe in the future, some startup will develop a service which takes my fine-tuning data and develops a more complicated computational graph of LLMs. So to some extent, something similar like that is happening in retrieval augmented generation, right? So here's my underlying RAG data set for my RAG application, and startups like Vectara will take that and automatically build a custom optimize RAG setup for you. And as many of you have heard me talk about in this podcast, retrieval augmented generation requires many, many choices along the way, right? So, like, what's my chunking strategy? What's my embedding model? Uh, what's my information extraction strategy? And so on and so forth, right? So many, many decision points along the way. So it would be nice if a service would just take your RAG data and somehow uh, do all of the computationally expensive experiments that require a distributed computing framework like Ray to do, and then give you your optimal RAG setup. So one thing that I've noticed myself doing, and probably a lot of you are starting to do this too, is I've been fine tuning LLMs on a much more frequent basis. Almost every week or every other week, I'm building a custom LLM, and the reason for that is that it's become really dead simple. So services like AnyScale's fine tuning endpoint really comes down to me coming up with label data, right? So, and there's many reasons why I begun doing fine tuning. One is that OpenAI service is can be slow, can be expensive, and sometimes can be unreliable, right? So if I know my task well, and I can come up with labeled data, then I can go to any scales fine tuning service and fine tune Llama 70 billion model. And the end result being I have a model that's even more accurate, even faster, and even cheaper, right? So in my mind, this task of supervised fine tuning is largely done for developers, assuming that you have labeled data, right? But unfortunately, fine tuning may not work all the time because one, it basically assumes that the data that you labeled is the same data that you will see in production. And as many of you know, there's distributional shifts between training and real world use that can reduce model performance. So one technique that people talk about is reinforcement learning with human feedback, because that can handle more, is more adaptable to nuanced data, right? So it doesn't, it doesn't, it's much more flexible and adaptable and can be done without explicit data labeling. So the problem there is it's actually a lot more complex as well, right? So you need to train a reward model, you have to do RL, reinforcement learning. And as far as I can tell, there's not many tools that are developer friendly in the way that I described supervised fine tuning, right? So for supervised fine tuning, all I have to do is focus on my labeled data set, which is a series of prompts and responses. Go to any scales fine tuning service, kick it off. I get an email with uh, my endpoint, my fine tuning custom model endpoint, and then I start using it. So I'm done, right? So it's that easy. So we don't have anything, as far as I can tell, for RLHF that's that developer friendly. So recently there was a paper from DeepMind that caught my attention, which might provide a middle ground in terms of, so as far as ease of use, maybe I think it's somewhere in between RLHF and supervised fine tuning. So not as easy as supervised fine tuning as I described it, which is really just composing your labeled data set at this point, but not as hard as reinforcement learning as human feedback. But more interestingly, it's has some of same advantages as RLHF in that it's adaptable to complexity, right? So it can handle nuanced tasks So the way it works is that you need two LLMs, right? So you need the LLM that you are tuning or aligning, if your task is alignment, and you need an LLM to basically serve as an annotator or a judge, right? So what you do is you send a prompt to your target LLM, the one that you want to tune or align. Let that produce two responses, and then your LLM annotator will evaluate those responses and then compares them and decides which one aligns with the outcome you want. Basically, it's simulating your preference as it were a human judge. And then what you do then is you take the LLM annotator's preference and update the LLM using a bunch of possible techniques like policy gradient methods. And then you do this iteratively, so continuously. And then that's how OAIF works. So right now, what I described to you is what's in the paper. So the next step here is to have someone build a tool that developers can actually use. And again, the nice thing about this is that you don't need a reward model like reinforcement learning, but you get the same benefits as far as responsiveness to nuanced tasks. So the next topic I want to talk about is AI integration, right? So obviously, as more and more people build LLM applications or generative AI applications, you want to be able to do that in a principled and systematic way. So we need more modular components rather than standalone solutions. So this signals a shift towards API-driven and modular software design to enable easier AI integration and also align AI models with specific applications and needs. So modularity is something to watch out for. All right, so you've probably heard me lament about the lack of founders, at least in the Bay Area, who are focused on domain and application specific generative AI startups, right? So it seems like most of the people I run into here are focused on general purpose tools or horizontal solutions. But one of the insights that my friend Ken So and I found when we looked at data and AI startups with over $100 million in annualized revenue, we found that many of such startups are actually focused on the application layer and they target specific personas and pain points. And that makes a lot of sense because there's a lot of different application-specific areas that are actually quite big that you can target. For example, I'm big on healthcare and financial services. You can poke around there. But, I mean, there's only going to be a few horizontal solutions by default, right? So I think that as generative AI capabilities progress, we will see more and more vendors targeting specific industries. So you might as well, if you're thinking of a startup, look in this area. And if you do, check out a recent paper from IBM where they lay out some really useful design principles for building generative AI applications. And I will link to it again in the episode notes. So another area that I'm fascinated with is generative AI for audio. Everyone knows about speech recognition and to some extent speech synthesis. And speech synthesis means voice in, voice out, right? So you speak, and then a model takes your voice and does something with it. Maybe gives you another voice, or takes your voice and translates it into another language, right? So the interesting thing here is the emergence of real-time speech synthesis. And here I point you to Meaning, a startup that I'm an advisor to, and their website is meaning.team. And they've cracked the nut as far as real-time speech synthesis. And if you think about how difficult that is, right? So not only do you have to take someone's voice and and process it, right? So either remove the person's accent or change the person's voice completely, but you have to do that all in real time as the person is speaking. Yeah, so it's a very difficult problem. But so Meaning's founder Yishai Carmiel gave a survey of generative AI for audio at last year's AI conference, where he opened with a mind-blowing demo, and I will link to that talk in the episode notes. So as more people talk about using large language models and foundation models and generative AI, quality control, risk mitigation, these are all going to be essential topics. I think right now, maybe the sense of urgency falls mostly on people who work in highly regulated industries like healthcare or financial services. But I think very quickly people have caught on that they need to do a lot of quality control and risk mitigation. So one possibility here is to build tools to help people automate some of these things, right? So for example, Anthropic proposed this notion of constitutional AI. Maybe you can take that idea and develop some tooling behind it, right? So in constitutional AI, you define a constitution, which is basically a set of principles that encode your values, right? So the values that you want, and use this constitution to supervise and reinforce learning in your model. So I think that actually this topic is so important that an entirely new set of startups, a new industry, focus on AI quality control, testing, and AI risk mitigation will emerge to verify AI systems prior, during, and after deployment, right? So, and two companies that I advise are worth following in this space: Luminos.law, the first law firm focused on AI and analytics. They help write the National Institute of Standards and Technology Risk Mitigation Framework here in the US, and Luminos.ai. And that's it. Thank you for listening. And if you haven't yet, please subscribe to our newsletter, which you can find at gradientflow.substack.com. And I'll be back next week, and we will resume our normal episode.